Welcome to our session on linear regression, where we're going to look at how two dependent and independent variables can be aligned. So linear regression is mainly about us understanding a framework that can give us what we can call a predictor. We're going to estimate parameters. It's part of hypothesis testing, and we're going to predict future trends using what we call linear regression. So to start with, linear regression is simply a technique that is used for modeling and analyzing numerical data. It exploits the relationship between two variables if it's linear, or more than two if it's multilinear, to gain information about one of them knowing the other values. So regression is actually used for 1, prediction, 2, estimation, 3, hypothesis testing, and for modeling causal relationships. So those of you who will be doing researches, it is at this point that I'm going to mention to say you need to start looking for topics. Topics for your final level. You cannot graduate without a dissertation, so you need to think of research topics, because this course primarily is meant to equip you with skills that will be essential for data analysis. So whenever we're dealing with topics that have to do with the relationship between, just know that you're dealing with regression analysis. So this is what we call the regression lingo, or the regression equation. Our y is called the dependent variable, and the x is called the independent variable. So the response is y, and the explanatory variable is x. The outcome is y, and the predictor is x. So y depends on x. Examples of relationships that exist in a firm are relations like advertising and sales. So which of the two is a dependent variable between advertising and sales? Which of the two is dependent on the other? So our sales depend on advertising. So our sales will be our dependent variable. Advertising will be the independent variable, the predictor. So when we're dealing with a regression equation, y in terms of x, so these are the variables we're going to look at. So a linear regression is given by y is equal to a plus bx, or y is equal to bo plus b1x, where bo is what we call our y-intercept, where it's cutting the y-axis. And the change in y over change in x, this is our b1, which is a slope. So this is the model. So we're going to look at how to compute regression equations of such a nature. So we'll go to the basics. So let's now look at how the regression equations look like. So let's start with the graphs. So we have figure 1 to 5. Figure 1 simply shows a positive relationship that is strong. Figure 2 shows a positive relationship that is weak. Figure 3 shows a negative relationship that is weak. Figure 4 shows a 0 or no relationship at all. And figure 5 shows a negative relationship that is weak. So collectively, y is equal to a plus bx. So this is the regression equation, which I said sometimes our a is equal to our bo and our b is equal to our b1. So regression analysis is used for 3 things. Number 1, to assessing strength. The strength is determined by what is called the coefficient of determination, which is r squared. It is given by SSXY over SSXX times SSYY. So in the event that you're given r squared as 0.9, this means that 90% of y is influenced by x. The variation in y, 90% of it emanates from x. R squared is 0.40, just multiplied by 100. This means that 40% of the variation in y is as a result of x. If your R squared is 0, it means that there is no relationship at all. So the relationships that emanate from this are relationships like sales and advertisements, age and BP, work experience and output. So these relationships exist that we can measure to ascertain whether there is a relationship at all. The second use is to measure the type, whether the relationship is a negative or a positive. So when the gradient is negative, just know that this relationship is downsloping. Our gradient is B. When the gradient is positive, just know that this is a positive relationship. So the other use is to tell you whether you have an inverse relationship, which is negative, or a positive relationship, which is positive. Clear examples that we know of are supply and demand. Demand is downsloping, supply is upsloping. And finally, regression is used for prediction. You can predict the future trend of sales, a probable BP, age, using a regression equation. So we're going to look at some formulas that will be useful in this segment of our class. Already we mentioned the regression equation being a plus bx, and the sum of square xx is summation of x squared over summation of x to the power 2 over n. So this is the summation of xx. We have x's throughout. Sum yy, we have summation of y squared, summation of y to the power 2, it's supposed to be y here. Then summation of xy, this is xy. There's x here, there's y there, there's n. So these ones are preliminary calculations that you need to have. Then our R stands for the coefficient of correlation, which I said is important because it helps us ascertain whether the relationship is a negative or a positive. When we square our R, what we get is called our coefficient of determination. So we can also use the regression equation to come up with what we call an ANOVA table, to use the ANOVA table to determine the significance of the regression line. So the ANOVA table under regression looks like this. We have the source of variation, which is the regression. SS stands for the sum of square. So sum of square regression, the degree of freedom is 1. The mean square regression, MSR. And the sum of square error is SSE. And the degree of freedom for the error is n minus 2. And MSE simply stands for the mean square error. These terms, you understand them further or later on. So I'm going to look at 2 examples here. I'll do one with you. You'll do the other one. That's your homework. So in this question, we're going to draw a scatter diagram, calculate the prediction equation, and find R and R squared, and finally to determine to what extent y is explained by x. So the first thing, when you have such, you transpose it and fill in the blanks as follows. So we're going to transpose that. So we have x and y. So we have 1, 2, 3, 4, 5. We have 1, 1, 2, 2, and 4. So to sketch, we simply use an x or y plane. This is x and this is y. So our diagram is drawn to scale. So here we have 1, 1, which is this one here. 2, 1, which is this point here. 3, 2, which is this point here. 4, 2, which is this point here. And 5, 2, 5, 4, which is this point here. Clearly, we can tell that the slope or the scatter diagram is upsloping, and the dots are close to each other, so it's a strong relationship. But we cannot be too sure just by looking, so we need to actually calculate. So whether indeed we have a positive relationship that is strong. So we'll come up with this table that we're going to fill in. So 1, 2, 3, 4, 5, 1, 1, 2, 2, and 4. So in this column, we're going to multiply 1 times 1, 1, 2 times 1, 2, 3 times 2, 6, 4 times 2, 8, 5 times 4, 20. Then we're squaring each of these ones here. 1, 4, 9, 4 times 4, 16, and 25. Then 1 times 1, 2 times 2, 4 times 4. So we're squaring this column here. So this is how we're getting this, and we're totaling up each of these elements there. And our n is 5 because the 5 pairs that we have there are simply giving us how many we have as our rows. So at this point where we've reached in filling the table, unless I'm a little bit fast, I'll ask for questions. Anyone lost on how we came up with this table? Okay. So if this table is clear on how we got it, we are now going to calculate what are called the sum of squares. So sum of square x, I said you just put x throughout. Summation of x to the power 2 minus summation of x squared minus summation of x to the power 2 over 8. So sum of square x, that's 55. Summation of x, which is 15 to the power 2, 15 to the power 2 over n, which is 5. So we're going to get a 10. Then we go to the y-y's. The y-y's, just put y's throughout. Summation of y squared is what? 26. You put 26 there. Summation of y to the power 2. Y to the power 2 is 10. 10 over 5. So 10 times 10 is 100 divided by 5 is 20. 26 minus 20 is 6. Then when we go to xy, summation of xy is 37. Then x times y, 15 times 10, divided by 5. So when we divide this in there, we get a 7. Because this in there is 2. 2 times 15 is 30. It's 7 minus 30 is 7. So these preliminary calculations are important for us to calculate the slope. Remember, I gave you the formulas for each of these. I said the slope, the error squared are very important. So our slope is given by sum of square xy over sum of square xx. Our a, sum of square or summation of y over n minus b, sum of x over n. So we're going to use the same figures that we just collected right now to compute what we need. So we'll start with our slope. Sum of square xy over sum of square xx. So what did we calculate our xy and our xx? So xy was 7, our xx was 10. So we're going to put 7 divided by 10. 7 divided by 10, we get 0.7. 0.7. Then when we go to our b has been calculated as our slope of 0.7, our r, sum of square xy over sum of square xx times sum of square yy. So where there is xy, we put 7, xx 10, yy 6. When we square root this one, we get root 60 into 7, which is 0.903. So this is our r. Remember, r stands for the coefficient of correlation. And at this point, we're only interested in the sign, which in this case is a positive. And so we could safely say our x and y are positively related. I must also mention that whenever the r is positive, it so follows that the slope is also positive. So when you square this guy, the value that we get is called our coefficient of determination. So r squared is going to be 0.816, which if we multiply by 100 means 81% of y is as a result of x. So we go to our a, summation of y, which was 10 divided by n, which was 5, we get a 2. Summation of x was 15 divided by n, which was 5, was 3. Then we just found our b as 0.7. So the answer we get is negative 0.1. So we substitute these figures now in the regression equation. So where there is a, we put negative 0.1. Where there is b, we put 0.7. So that we get our regression equation. So since we know that our regression equation y is equal to a plus bx, where there is a, we put what? We put negative 0.1. Where there is b, we put what? 0.7. So this becomes our prediction equation, which will give you 5 marks. Part A was the scatter diagram. Part B. See, if x is 10, what is y? So where there is 10, we put, where there is x, we put 10. So we're predicting. So here we're going to have negative 0.1 plus 0.7. Here we put a 10. So the answer we're going to get is what? 6.9. We've predicted our y when x is 10. Then we go to our d, which is asking us to find our r. Remember, our r was given by what? Summation of squares x, y over summation of squares xx and summation of square yy. Eventually I'll teach you how you can use the calculator. Those I made physically, they were able to do the leakage way, where they just pumped in these figures and they were able to get all the answers correct. Now they were lazy, they started asking whether it's possible to just put the answers without showing. Mature tapona lava field. So when you put this here, you're going to get 0.903. So this is what we call our relation coefficient. So this means that x and y are positive. Then when you square that, we're going to get 0.816. So this means that what? 81.6% what of x is influenced by y. 1.6% of what? Y is affected by x. So this is a meaning. So let's try another question together. If you're given x and y, so here we have 2, 4, 6, 8. Here we have 10, 6, 8, 5. So now we're being asked to come up with the regression equation. So we find this column xy. How do you find this column xy? How do you find x squared? And how do you find y squared? Quickly, the ladies, the guys, the baby.
xy by x by y, which is 2 by 10, to give us 20. Same with 6. 6 by 8.
48.
48. 30.
16, 36.
Yeah.
100.
100.
36.
36.
36. Yeah.
25.
What process are we doing now? Okay, ladies do the first two, gents do. Ladies do the first three, gents do the last two.
$20.
20.
Yeah.
Mhm.
29.
Mhm.
That's 132.
130.
138.
138. 138 or 130.
132.
And here,
120.
and here,
225.
225.
Mm-hmm.
Now n is what?
4.
4.
Okay, so what is the sum of square xx? Who remembers the formula? Small x is here. Okay, who remember the sum of square yy?
Ma y yeka yeka.
Oh, I sorry. So here you put it. Then xy.
Summation x y minus summation bracket summation x times summation y over n.
I know this man is spoon feeding you. He'll be giving you formulas, but I'd rather you have them at your fingertips. Then what is our d? Xy over. Now r. Summation of xy, just the same one, but we're just putting it in the square root now down there. Summation of xx times what? Summation of yy. Okay, then how do we find r squared?
R times R.
R times r. And how do we find our a? Summation of y over n minus b division of x
Over N.
So everything has been done for you now. Give me the answers. I'm going to give you 2 minutes. Start solving. So if your calculations are well done, you will find that the sum of square xx will give you 20. The sum of square yy will give you 14.75. The sum of xy will give you minus 13. And to find the slope, which is b. And this b, like I said, could also be b0 in other books. Is xy over xx. So these figures that we got here are cardinal and paramount to calculating what follows now. So sum of square xy over sum of square xx. So you just pick the figures as they are. Minus 13 over minus 20, we get what? 0.65. So this is our slope. Now this slope is part of the intercept, the A formula. So if you get this wrong, it means your A becomes wrong as well. So to find our summation of our value of A, it's summation of y, which was 29 over 4, minus this very B, minus 0.65, you put it here. Then summation of x was 20 over 4. The answer you're getting is 10.5. So these two make what we call the regression equation. So where there is x in this regression equation, where there is a, you put 10.5, where there is b, minus 0.65. So you're done with predicting the prediction equation. So they will later on ask you find now the value of y. If x is 10, so sometimes this value of y or this value of x would be a figure, a variable to say, suppose advertising was 10,000. What are the sales? When you put there, your answer is 4. Maybe that is 4 million. All right, so this is your prediction. And now they ask to find the coefficient of correlation. The formula is SSXY over the square root of SSXX times SSYY. So 13. So what you need to remember is the B is very slightly close to the R. Just add times the SSXYY. Then you square root them. Be careful, start multiplying this square root and you divide it in the answer. So you see, whenever your slope is negative, it also follows that your R will be negative. So here we get 0.76 negative. Our interpretation is simply that x and y are negatively or inversely related. Then squaring this answer gives you 0.573, which means 57.3% of y, or the variation in y, is as a result of the variation in x. So basically, that's what regression is about. And if there are any questions you could ask at this point.